So let's say we have an equilateral triangle and its incircle. What is the ratio between the area of the incircle and the triangle? I'll just call it T. Well, let's find out. So we know that the area of a circle is represented with this formula, pi r squared. And then the area of a triangle is going to be 1/2 base times height. So in order to find the ratio, we need all of these variables to cancel out. But since they're not the same variable, we have r, b, and h, we can't do that. So what we need to do is take b and h and write them in terms of r. So how can we do that? Well, first things first, I'm going to move this up here so we can see it for later. Now let's begin. So here's r. There's the center of our circle, and there's r, because that's the radius. And here's h. As we can see, h is going to be these two radii plus this little bit. So how can I find that little bit right here? Well, if I draw a radii to here, I notice that I have a triangle. And this, in fact, is a right triangle. The reason that I know that is because if this is an incircle, then all these sides are going to be tangent to that circle. And an interesting thing about tangents is if you draw a radius from the center of a circle to the point of tangency, it will always form a right angle. So that's why we know that this triangle that we just made is a right triangle. And this is really good because if we find the hypotenuse of this right triangle, all we have to do is add r, and that expresses h in terms of r. Oops. So let's bring out this right triangle. We know that the smallest side is r, right, because it's the radius. What else do we know? Well, up here, this angle in total is 60 degrees. We know that because every angle in an equilateral triangle is 60 degrees. Now, if this is the incircle, and we draw a line from the center to a corner of the triangle, then this line will bisect the angle. This means that this whole 60 degrees got split in half by this line. So that means this degree, or this angle right here, is 30 degrees. And that's inside a right triangle, so let's draw that right there. And that means this last angle is 60 degrees, because they all have to add up to be 180. Now this is a 30, 60, 90 triangle. And these are very special. So if I draw over here, because we're probably going to have to be using these, 30, 60, 90 triangles have this ratio between their sides. If you have the smallest side as x, then the hypotenuse will be 2x, and the middle or the medium side will be x times the square root of 3. So we can use that up here. We know what the little side is, and we know that the hypotenuse will always be 2 times this little side. So this is 2r. And the medium side will be r times the square root of 3. So that's a really cool way that we just used 30, 60, 90 triangles. So now that we know this, let's move all this out of the way. We now know that this whole length right here is 2r, and we also know that this length right here is r root 3. So now we have enough information to find what h is. So h is this whole thing, right? And we know that this part is 2r and this part is r. So that means h is simply 3r. Now let's just find what b equals. Well, fortunately, we actually found part of b. So since this is an equilateral triangle, any of these sides is the base. As you can see, these two segments are going to be equal. The reason that I know that is part of the property of the equilateral triangle is that the incircle is going to, the center of the incircle is going to be equidistant from every vertice. So these are all equal. As you can see, these make the little right triangles, right? So these two right triangles are going to be equal because they have the same shortest side and the same hypotenuse. So that means these parts are equal. What does that mean? Well, that means that this part right here is also r root 3. So that means the whole side is going to be 2r root 3. And so now we have expressed h and b in terms of r. So now that we have that, we can finish our ratio to see if the variables will cancel. And that way we can get our ratio. So pi r squared, that's going to stay the same. And then at the bottom, we're going to have 1/2 of b. b is going to be 2 times r times root 3. And then it's going to be times h. And we know h is just 3 times r. So right away, I can see that 1/2 and 2, that's going to equal 1, so they're basically just going to cancel out. R times r, that's going to be r squared. And then we have just 3 root 3. So that's the bottom of our ratio. So let's rewrite it. 3r squared root 3. And as we can see, indeed, these r squares are going to cancel out. So we're going to have pi over 3 root 3. So this is our ratio. Let's clean it up. You're technically not supposed to have radicals in the denominator. So let's get rid of those. We can get rid of those by simply multiplying the top and bottom by itself. So at the top, right here, we'll have 3 pi root 3. And then the bottom, 3 times 3 is 9. Root 3 times root 3 is just 3. And now we have 3 on the top and bottom, so we can cancel those. And so our ratio is going to be pi root 3 over 9. And so that is our ratio.